Okay, this is the second video to show the Cairn era cost model and how to work it. So we've got essentially four sections here. We've got the yellow tabs in front are the overarching visualizations. It's the dashboards, cell level sensitivity analysis, and charts. Then we've got the cost model itself, and that's broken down into an anode tab, an electrolyte tab, and then a cathode salt tab to make the nickel sulfate, cobalt sulfate, etc. Feeds into the cathode tab, and then all of these feed into the battery manufacturing tab. The third section are the inputs. We've got inputs throughout this entire workbook. However, these inputs pages in the light green tabs are essentially, they're only inputs in these tabs. So let me start by going to electrode inputs. One big point is you want a big screen. If you've got a large monitor, that helps a lot. This is a very dense document and hard to visualize, hard to put on a small screen, but that gives you a sense of also how powerful it is. So on the electrode inputs, first of all, we've got the various proportions within the cathode materials, as well as their properties, including specific capacity, which is one of the most important to figure density. You've got the tap density, the cathode powder. You've got the overbuild of the anode here, or overuse we're calling it, because you're building the anode, you're curling the edges of the anode around the cathode, so there's usually a little bit more anode material. And then you've got the tap density. Now all of these come through the columns that are written on row 3. So they're the various cathode materials, but then they're the various anode materials. So what it's going to do is when you put in a tap density or a specific capacity for material for an anode, let's say it's 350 instead of 372 for synthetic, things will self-calculate accordingly. Same with the cathode. Let me just put that back before I forget. Then going on to further out here, we've got the various the silicon graphite composites that are built into the workbook. The way that we manage essentially there's a lot of calculations going on. So it's all of these proportions, weight, percentage of components are feeding in from a lot of different adders. So the one where you can, the way we built it is the one thing you can do to alter everything else, in addition to everything where this information, where the weight information is coming from, is change the proportion of electrolyte. That will automatically change everything else. Every one of these materials, you're going to have a method of changing it, but in this weight percentage of each component, the master knob is the electrolyte percentage. You can, and then everything again is, we're breaking that down into form factor. So if you've, whatever form factor you selected on that dashboard page, that's what it'll be reading from. You can then go into the additives and binders and change those in the proportions that are being put in the battery factory. Here's the single most important one, I think, on this entire page for making changes, is the thickness of the cathode. So we're putting it in at 55 microns as kind of an industry standard, but here, this is where a lot of things change when you change this. You also, for cell, you don't necessarily need to be working on the cell level where you're specifying the proportions of the cell, but you can do that here. But really, everything else is done in the workbook is done on a kilowatt hour level, not a cell level. But by putting in dimensions of the cell, in this case a pouch cell, you can see some of these outputs on the pouch cell. on the actual cell, not just the kilowatt hour of battery. So then I think where you end up with these outputs that feed elsewhere into the workbook are rows 61 through 63, column C, and that's going to give you the watt hours per liter and watt hours per kilogram. That will be important elsewhere. In terms of other components in the battery, the cover, the pouch, tabs, etc. The way we're handling that is just to put a percentage number on the percentage of that battery that is in the weight of this particular material. So we end up with 1.9% in the pouch battery as other components. In this input, that might be a little bit too low, but that's how we do the other components. Last thing on this page is the weight in slurry. So this is going to feed into the battery manufacturing tab. And essentially what you're saying is when it's mixed, how much active material is mixed and is put into that slurry, and it will automatically fill that with the solvent in the battery manufacturing tab. A 60% solid to solvent ratio is pretty, I think, not standard, but it's common. So that's where we are. And you can do the same thing. But you can change that to see how it changes things. You can do the same thing on the anode. Okay, the other major inputs page is the cost inputs. And I'll go over this quickly because I think it's pretty apparent with a couple issues around it. Number one, you start out here. So if you scroll down the page, you start out with the scale factor inputs, which I'll come back to. Then you get into the materials inputs. That goes through each of the battery components, the cathode, the anode, the electrolyte, etc. Then you've got a packaging inputs section for the inputs there. Then things like energy rate, labor rate, and then we go into the various scaling factors. Okay, so let me explain scaling factors very quickly. What we're trying to represent here is what are your economies of scale when you have a larger factory or a smaller factory. Everything is balanced at 5 gigawatt hours. So at 5 gigawatt hours, the scale is 1.0. You can change this scaling factor and it will stay at 1.0 at 5 gigawatt hours, but the others will adjust at a sharper or less sharp scaling factor. So for instance, at 1, when it's set at 1, everything's the same. A 0.01 gigawatt hour factory, which would be a 10 megawatt hour factory, when you set the scaling factor at 1, it's the same economy of scale as a 5 gigawatt hour. Now I put it down to 0.9 and everything goes crazy. So now you're still at 1, your standard or baseline is 5 gigawatt hours, but now you're at a 0.93 scaling factory when you go up to 10 gigawatt hours. You go all the way down to 0.84. So in other words, if you're setting the scaling factors here for all of the different things, but for the commodity minerals, say you're buying nickel, and I'm saying the scaling factor is at 9, and it costs $1 when you're operating a 5 gigawatt hour factory. It costs 84 cents when you operate a 30 gigawatt hour factory. In other words, you're saving 16 cents or 16% because of the scaling factor. So a lot of these are kind of just universally set to relatively moderate ones, but it's something you can play around with to determine how much the scaling happens. So what you're going to do is all of these are inputs. So for instance, we've got let me find a good one. LC. In this case, it's this is a lithium carbon equivalent price, and let's put it. I think we've selected the U.S. I'm going to say it's $12 LCE per kilogram price. And what's now, we've selected our scaling factor here. I think it's 0.9. So when you go back to the workbook, it's not going to say $12. It'll show that, but in fact, it's going to show whatever we've selected a 35 gigawatt hour factory. It'll show that $13 number, that's what you're paying for lithium carbonate equivalent when you're operating a 35 gigawatt hour factory. And it's that number because for some reason, earlier I selected a scaling factor above 1, which in almost all cases doesn't make sense. But regardless, that's how the scaling factor works. So we've got every possible material in here. Some of these are not connected. The lithium metal and all these next-gen materials are currently not connected. We're doing the silicon and cost model differently. Eventually, we'll reconnect these. But others, we're trying to put in our own prices based on when we get quotes. We're trying to show regional variation where appropriate or where we can prove it. And we are, we're doing the scaling factor according to what we think works. And so that's that page. And then all of you're going to, again, just to emphasize, any yellow cell is an input cell. You can input something. You input something into almost any of these white cells, and it's going to mess up the formulas. So only change the input cells that are in yellow. So you're going to put in your electrode inputs you want, you're going to put in your cost inputs that you want, or change the ones that we have set in already, and those will all feed into the actual cost model. So that's the end of this video. On the third video, I'll go through the cost model itself.